Hi, and welcome to the Anti-Waffle podcast of Em and Pixie.
Woohoo!
And together we'll try to talk about research about any gobbledygook. Each episode we'll be talking to a researcher who will discuss the work they're doing, looking at why this research is important and asking how did they get into this field. We hope that it will be informative and interesting and bring a bit of the academic world into the real world. Today we've got Dr. Chloe Park, who's a researcher in cardiovascular physiology at UCL. Hi.
Hello.
Hello, thank you very much for being here.
You're welcome.
Thank you. Would you like to start by telling us a bit about your research, please?
Sure. So I'm a physiologist, so I'm interested in the mechanisms of how the body works, especially the cardiovascular system. I want to know how the heart changes with age and disease, and I want to know how the heart interacts with the arteries and how in turn they both interact with other organs such as the brain.
Oh, that's really exciting.
Wow. And how long have you been doing your research for?
So over 10 years now. So my PhD used a technique called wave intensity analysis. That sounds scary, but basically every time the heart pumps, there's a wave generated that helps to propel the blood flow around the body.
Right.
And there are components of this wave that you can measure, blood pressure and blood velocity. If you measure them together, you can use this technique to tell you about how well the heart's pumping and to tell you about the arteries that it's pumping into and how they're working together. So that was my PhD 10 years ago, and I applied this technique to different sets of data to see how the interaction between the heart and the arteries changes when you change things about either the heart or the arteries. And then at the same time, I ended up working on another study at Imperial College London with Professor Anish Chaturvedi and Alan Hughes, who I still work for now. And this was a completely different subject, so not related to my PhD, but in exchange for data, I worked on a study looking at ethnic differences so there's big ethnic differences in rates of cardiovascular disease. So if people from South Asian ethnicities are far more likely to suffer from heart disease and stroke compared to white Europeans. And so this study was trying to find out why. And so they were measuring...
And that was using the same wave technique?
So this was using ultrasound to look at blood flow in the brain. And then my job was to look at blood flow in the skin and how it changes with heating or with a temporary occlusion. So you temporarily stop the blood flow and then what happens when you release it.
Yeah.
And this was, like I say, in exchange for data for my PhD, but it gave me clinical experience in dealing with participants and opened me up to a world of epidemiology because I came from a physiology and bioengineering background.
Right.
And so what they found in that study was that there are ethnic differences in the way that the microvasculature responds that might help to explain increased rates of cardiovascular disease and strokes in South Asians.
Right. Oh, so you were looking at the skin because it's different ethnicities, and so that's where our difference lies. So our hearts are pretty much the same, but the skin is the differences in the skin. Is that what you're saying? Is that why you're looking at the skin
rather
rather
the colour
than...
of the skin is about the way that the blood vessels react.
Right.
And
I see.
Slightly different.
And it's easier to pick it up in the skin.
Yes,
than
and you
in
need
the...
to be able. Yes, you need to be able to get to the area to look at it.
Right.
But that was my first experience with epidemiology.
Right. Okay.
And then while I was working at Imperial, I was offered a postdoctoral position on a new study they had just got funded. And that was also looking at ethnic differences, but this time it was a tri-ethnic study. It was called Southam and Brent Revisited, a 20-year follow-up study looking at ethnic differences in cardiovascular disease. So the population was white European and first-generation migrant South Asian and African Caribbean. Because we know that there's different risk factors and there's different rates of disease with ethnicity. And we're trying to figure out if we can cluster the risk factors together, does that explain why certain ethnic groups have more cardiovascular disease than others? So, for example, South Asians have far more cardiovascular disease than white Europeans and far more diabetes. Mm-hmm. African Caribbeans have less heart disease than white Europeans, but they still have a lot of diabetes. So they were trying to figure out, well, is it the diabetes itself, and why is that only acting in one ethnic group and not the other? And so what Saber found was that diabetes has a toxic effect in South Asians. So if you took 3 people, one of white ethnicity, one South Asian and one African Caribbean, and they all had a high blood sugar level, that hyperglycemia would have more of a toxic effect in our South Asian participants compared to our white European and our African Caribbean.
Oh, and so it's the toxicity of the diabetes that causes them to have more heart disease?
Yeah, possibly.
Possibly. That's what you're looking at. Oh, that's fascinating.
And why? Why do you...
Well, that's
yeah.
Well, that's what you're trying to ask.
Yeah.
That's why you get paid the big bucks.
So my part of the study was to work in clinic, collect the heart data and the other vascular data. And it was the first study to ever use 3D echocardiography to look at ethnic differences. So that's ultrasound, like you would use to look at a baby in a mother's tummy, but use it in the heart. And this 3D at the time was very new, and it allowed us to get a full picture of the heart. And what it showed us was that heart mass, the walls of the heart, are not as thick in our South Asian participants, despite even when you've adjusted for a smaller body frame or other risk factors.
Yeah.
And because of that, the oxygen demand of the muscle is higher, and that might contribute to higher risks of coronary events in South Asians compared to the other two ethnic groups. And then also you have to add on the fact that this diabetes has an extra toxic effect on the function of the heart and the arteries in South Asians compared to the other two groups. So that
So
might
we've got
explain
thin
the
heart walls and
differences.
toxic. So sugar is toxic to them.
Yeah.
Oh,
We don't know why.
I'm glad I'm not.
Ongoing.
I like my sugar. No. So are you finding, or have you, if you've gone down this road, are you finding a difference between like South Asians and also African Caribbeans, where if they were born here, if like with that generation that are born here, or those who were born there, is there a difference there?
We think there probably is.
Yeah.
In America, rates of African Caribbeans having heart disease is much higher. I mean, that's probably a generational effect. So perhaps the next generation in the UK will see a difference in the trend of the rates of cardiovascular disease.
And it might go up even more.
Yeah.
Ooh. Oh.
Wow.
Sorry, I was born here. Wow. And so what will you do with the information?
Well, so we can try and use it to enforce policies such as treating blood sugar at diabetes at an earlier stage in South Asians. So the cutoff for saying, oh, you have pre-diabetes or diabetes should be earlier, should be treated earlier in South Asians. It shouldn't be one rule for everyone. And that's something that has come in since our study.
Right.
Brilliant.
Wow.
I also look at the structure and function of the heart in other cohorts. So not just looking at ethnic differences. I've also been looking at how your heart changes from when you're a teenager to when you become an early adult, so from the age of 17 to 24.
Right.
And I do this in a large birth cohort that started in 1990 called Children of the 90s, or OLSPAC. And it was over 15,000 pregnant women were recruited in the Bristol area.
Yeah.
And both the pregnant women, the babies, and now the babies of the babies have been followed up ever since.
Wow.
But the original babies are coming up to 30 years old.
Right.
And they had their first full cardiovascular assessment when they were 17, and then again at 24. And the reason we wanted to look at what happens during this time is because nobody's looked at it before. You just assume that you're young, you're healthy, you're invincible, nothing's going to change. But what we found actually is that the heart does change between 17 and 24, and that you have an increase in your heart muscle mass, and your diastolic, so your resting function of your heart, is already declining by your mid-20s. And it seems to be related to increased fat mass that you put on during that time. We know that it's an important time in the life course between adolescence and adulthood. You move out of home, it's a peak time for risky behaviours like smoking, alcohol and drug taking, and we wanted to think, well, how do these big lifestyle changes affect your cardiovascular system?
Right.
And they are having an effect even at a young age.
So the heart mass is getting thicker. But I thought that was a good thing. I thought that was...
So it does it to equalise stress and strain. The heart wants to be very efficient. It wants to run on as minimum oxygen as it can. And so to do that, it changes shape, which is good initially because it means that you're equalising the stress. but eventually that shape change has knock-on effects on the function of your heart. So the heart starts off like a rugby ball and it ends up more like a football. So it doesn't work quite as efficiently. So increased heart mass is known to be associated with cardiovascular events later on. So if you've already got a higher heart mass by your mid-20s, it's not a good thing.
So how do we address that?
Yeah.
Is it that you would start saying to young people who don't listen?
Well, that's the thing. We can tell them, if you put on such and such 5 kilos between 17 and 24, this is going to have a bad effect on your heart.
Yeah.
You can tell them that, whether they will listen or not.
Why? Because they think they're invincible.
They're young.
Interesting.
And have you seen, for a side question, but have you seen that, are they more interested in sort of exercise and things, these people that you've been monitoring? I just wondered whether, because they knew they're being monitored, whether that was affecting.
No, there's a real mix. I think because they've been involved ever since birth. It's just part of their life. They go to the clinics. They've been measured since they were 7 in other areas, not cardiovascular, but for cognitive function and other areas of their life. They've completed 60 questionnaires throughout their life, and they've had various tests. So it's just part of
what they do,
what they're used to. Yeah.
And is it just for? Are they being tested for other things as well? Is this test sort of covering other research projects as well? Are they being used?
Yes, yes, the whole wide range of questions.
It's fascinating.
Have you had any of them drop out? Because, it's the mothers really who volunteered them. So I never signed up for this. Show me my signature.
Get busy. So originally there were 15,000 babies. And in the last clinic, 4,500 people came in.
Oh, wow, that's a big drop.
Still quite a lot though, isn't it, to measure? Wow.
I think as they get older, they move away, it's been dropped further, but that is the problem with
Do you think that's why they started with so many, because they knew that you're going to get the drop-off, so I suppose.
Oh, that's an interesting study. And has your project got an end date? Is your research that you're doing, was it just ongoing forever?
No, end date. And in fact, I'm trying to apply for a fellowship to get funding to be in charge of my own study in the future. And that's going to be looking at something slightly different again, but using this young cohort. So in the older cohorts, the tri-ethnic cohort that I spoke about, I looked at the way the heart changes, but I also looked at the link between the heart and the brain. So if you have poor heart function, you tend to score lower in cognitive tests. And we're not sure the exact mechanism, but it might be that you're just not pumping enough blood up to your brain. We're not sure, but cross-sectionally I saw that those that had poor heart function had both lower scores and smaller brain volumes.
Oh, wow.
And so I wanted to look at that in different cohorts to see if I could replicate my findings. So I looked at it in the original 1946 birth cohort, where they had cardiovascular assessment in their 60s, but they had cognitive function assessed throughout their whole lives. So I could look at the heart-brain association from both directions. So what I saw is that from the heart to the brain, I could replicate the SABRE results by saying those that had poor heart function scored lower in cognitive tests. But then I could also reverse the arrow and say, well, actually, those that had lower cognition as a child had more cardiovascular disease as an adult. So the connection between the heart and the brain seems to run in both directions. So for my future research, I think that we need to start looking at this connection in a much younger cohort, which is where the Ulsbach cohort comes in. They're 30 now, the babies, this year. And I think this is the perfect time to start looking at the mechanism, linking the heart and the brain. So that's what I hope to do in the near future.
Wow,
that's exciting. So with the cohort that's already there, have you got the measurements that you want to take now? Have they been taken before with them, so you can actually look at their history?
So they've had cognition since they were 7. And they had full cardiovascular assessments at 17 and 24. And I want to bring a subsample back and give them very detailed cardiovascular measurements during exercise, simultaneously measure the heart and the brain to figure out if there's a mechanism linking the two that can help to explain the connection.
That's interesting. Good luck.
Thank you.
Have you always been interested in the heart and the brain? Did you like study biology?
Yes, more so the heart. So I liked science at school,
Right.
and I knew when I was doing my A-levels that I wanted to go to university to study science, but I didn't know which branch of science best suited me. And so I ended up doing biomedical science at King's College London, because in the brochure it said, for people that like science but don't know what they want to do.
That's me.
So you get to try a little bit of everything. So I tried microbiology, immunology, genetics, everything.
Yeah. Cool.
And so you try all that in your first year, and by your third year you get to pick which units you take that suit you. So by the third year I was taking more physiology units and more full system physiology rather than cellular physiology.
Yeah.
And especially the cardiovascular system just appealed.
Excellent. Any regrets?
Was there an alternative plan if you weren't going to go into this? A dream?
No, not really. So after I finished my degree, I went travelling, and I kept an eye out for PhDs that were being offered. And I was in the middle of Vietnam somewhere, and I saw a PhD being advertised in the bioengineering department at Brunel. And even though I wasn't an engineer, it was applying this technique, rare intensity to the cardiovascular system.
Yeah.
And it appealed to me. So when I came back, I interviewed, and a few years later I started.
Yay!
Wow, that's brilliant.
Excellent.
And if you had to sum up how to sum to the public why your research is important, could you do that?
Well, I hope that my research is going to help the public. I hope that the things I find out can help people to live longer and have healthier lives. And we need to find out, in order to help people, we need to find out about the mechanism. I don't just want to know how the heart and arteries change. I want to know why. Because unless we know why, we can't stop it or prevent disease going further. And with the heart-brain connection, for example, dementia's on the rise. It's going to triple in the next 20 years. There's no cure. But the cardiovascular system does play a role. So if we can find out the mechanism between the heart and the brain, we can try to prevent or at least delay progression of dementia.
Yeah, we should know what we're looking for.
Yeah, that's so important. Yeah. Well, thank you very much, Chloe, for talking to us. It's been lovely. Thank you.
Thanks for having me.
Thank you. And thank you very much to everybody for listening. Please do get in touch, as we'd love to hear from you. Bye.
Bye.